Okay, however, what is important for us is not just one element. We want to say we have a map that works for a whole set. How do I define it? I just say I want to say my set. It would be a set, so I will show it with curly brackets and just equal sign, because I'm saying the map of A is a set that each element of A that would be in map F belongs to A. In a way, A is contained or is equal to B. Also, another way that I could show it would be A would be map of element A is defined in such a way that A belongs to A, set A, and A is contained or is equal to set B. Maybe this is more accepted, the second one. The first set, or A, is called domain. An element of set A are called argument. What is here is called argument. Set B is called codomain. And f of A as a whole is called value or image. And the reason is, if for instance I have a set A, if I have a set A and it's called 1, 2, and 3, and my rule F tells me every element should be added to 1. My set B would be 2, 3, and 4. So for every element I have an assigned element. So 2 is image of 1 in map A, map F, 3 is image of 2 in map F, and 4 is image of 3 in this scheme or map. I can write my map F is something that brings A to second form B. This is not B, by the way. B. Also, I can say element A is something that goes to map argument image F, value F. And please notice that here and here I didn't use the same flash arrow. If I have a map that assigns for every element of A an element of B, like this one, I can also do the reverse and show the reverse with -1 is equal, which is bringing B to A. Okay, now let's talk about composition. Composition means nothing than we have two maps, which means the first map, as already mentioned, we plus every element, we add to each element of A 1, and what we receive, we put it as B. And let's say the map B says, okay, we multiply it by 2. So what I have here is 1, 2, 3. For the map B, I would have 2, 3, and 4. It comes here, and multiplied by 2 would be 4, 6, and 8. How do I show? If I want to show, for instance, a friend where I brought these numbers, I would say this is a function of G, O, and F, and the second one, O means of, and the second one is always what was the first function, and this is the second function. Another way to show G of F is the function, the function of F of A. So this is the first one, and this is the second one. To sum it up, a map is just a word, a rule. So to say, you show a hole in a wall, that is your codomain, and you show your screwdrivers or screws, and you say, and that's your set A, and you say that hole will be done, you will make that hole on a wall using the screw in set A. I'm sorry, the hole on the wall is the product. Is not the second set. The second set would be using this rule, using the screwdriver would be your set B. Thank you very much. The next video would be about maps, would be about groups. And yes, have a good day, have a good night. Bye bye.